Hello, in this video we will look at strategies for analyzing the relationship between two variables. This is sometimes called bivariate analysis. So one of the first tools that we have is called a scatter plot or a scatter diagram. So the way this works, we have two variables. One of them is called the explanatory variable, and we often use an x to represent this variable, and the other is called the response variable. And we often use a y to represent this variable. Sometimes the explanatory variable is called a predictor variable. So I'm just going to write that in there parenthetically. In algebra, you sometimes call the x variable the independent variable and the y variable the dependent variable. In the field of statistics, I think we refrain from using that because dependent has a very specific meaning in statistics. So we'll call this explanatory and response. Again, we'll use x for explanatory, y for response. And you may recall from previous videos or reading that this has come up when we've discussed both observational studies and designed experiments. And so usually we're looking, or we have a suspicion, that the explanatory variable has some sort of impact on the response variable. So to investigate this relationship between the two, in the practice of statistics, we will gather data. And so we're going to pretend that we've gathered some data here. So I have values for my explanatory variable and values for my response variable. And I probably gathered this data from a number of individuals or objects. So this may be the first person or object in my sample and so forth. And so maybe I have 5 people or objects in my sample, and I have values for x and y for each of these individuals or objects. So to construct the scatter diagram, I will cross a set of axes. On the horizontal axis, this is where I will find my explanatory variable values, and then on the vertical axis, this is where we'll locate our response variable position. So a scatter plot, I'll mark each of these just like an ordered pair with a position along the x-axis for the explanatory value, and along this vertical axis for the response value. And so I might end up with something that looks like this. I'll have one marker for each of these observations, and you can think of it again like an ordered pair where I have an x value and a y value. So yeah, this is just like plotting ordered pairs in the Cartesian plane. So what do we do with this information? Once we have a scatter plot, there are two things that I would ask you to consider. First, is there an association? So that could be either positive or negative. And so a positive association would mean that there is an upward trend, and that would be as we look from left to right. Left to right. And this would mean that larger values of the explanatory variable are associated with larger values of the response variable. And we can see that here. In this scatter plot that I sketched, there is a positive association. There's a general trend upwards. So notice that, for instance, for this data value, it would have a relatively low x value and a relatively low y value. Looking at this scale, so this x position is low and this y position is low. On the other hand, if I look at this data point, it has a relatively high x value and a relatively high y value. So low with low and high with high. If we have a negative association, then we would expect a downward trend. And that is left to right. And then we would expect larger values of the explanatory variable to be associated with smaller values. So that may look like something like this. So there's a downward trend, and so as I move, look at the values that are with x coordinates over on the right hand side. They have y coordinates that are relatively low. So for instance, this one has a high x value but a low y value. Let me just move that to where you can see it better. Again, so this point has a high x value and a low y value. So that's characteristic when we have a downward trend or what we call a negative association. The second thing that we would look for in a scatter plot is to see if there is a pattern. And for now we're going to keep it simple, and we'll limit this to three options: a linear pattern, a nonlinear pattern, and then just no relation. So a linear pattern, that could look like what we've seen in these previous examples that I've drawn, where the points in the scatter plot fall on or near a straight line. Now, sometimes they may fall perfectly on a line, but really you have to give yourself a little bit of leeway, and I think on or near a straight line is sufficient to say that there's a linear pattern. There are other patterns that are nonlinear. So for instance, let's say if we have data, and when we look at the scatter plot, we get something like this. So there is a pattern here. You may recognize this from other math classes as being parabolic. That looks like a parabola. So that's certainly a pattern. It's not a straight line. And so this would just fall under this kind of catch-all of nonlinear. And then finally, if we don't see any pattern at all, so there's just a random display in the scatter, then we'll just say that there's no relation. So here are the three options that we'll look for. So again, look for association and then for a pattern. In the next video, we'll look at some ways to quantify this association and pattern. I hope you join me for the second part.